everyone, it's Ben Jones with dataliteracy.com. This is our first Whiteboard session. Instead of Webinar Wednesday, this week we decided to do Whiteboard Wednesday. And I want to cover a very important topic, the 4 types of data scales. Now, this scale system came out of the 1940s when a Harvard psychologist named Stanley Smith Stevens, who was trying to collaborate with other scientists and researchers to measure how loud humans perceive sound, found that he had to come up with a common system in order to be able to make progress. So he wrote a paper called On the Theory of Scales of Measurement, which you can find online. So we're going to use wine as our example as we go through these 4 data scales because the scales spell the word noir. The first one is nominal. And those are like names of things. And so they're just characters there. There's symbols that are scattered randomly. There's no notion of order. What would that be with wine? Well, I could use a lot of things. Let's go with maybe the type of wine, like Pinot Noir. It could be Cabernet Sauvignon. It could be Merlot, right? There's lots of different kinds of wines. I'll pick that one. Now, what does this give me? It gives me the idea of equal to or not equal to. And because of that, I can count the number of cases of a thing, and I can also find the mode. So if I have a crate of 100 bottles of wine, how many are there of each type, and which type is most frequent or common? That would be the mode. But there's no notion of greater than or less than, which is what we get when we look at ordinal data scales. So this might be like the rating. Maybe you rate a bottle of 5-star, I rate it a 4-star. We have the notion of greater than or less than, and the order is always preserved. And now I can also compute median, and I can compute percentiles, which is useful. But what's interesting about ordinal, as you can see from the symbols I drew here, is the distance between subsequent values in the scale might not be the same. So just because I go from a 1 to a 2, that doesn't mean the wine improves the same amount as if I were to go from a 3 to a 4 or a 4 to a 5. So in the same case of ordinal, I have order, but not necessarily distance. Distance is what we get when we look at interval data scales. So now I have preserved the distance, but what's interesting about this is that the 0 value is arbitrary. So that would be like temperature. Let's say if I said, what temperature should I serve up this wine? Well, you say it's a Pinot Noir, which, as everyone knows, that would be 56 degrees Fahrenheit. I didn't know that until I looked it up. But you might say, oh, Ben, if you had a Merlot, it would be 62 degrees Fahrenheit is the proper temperature to serve the bottle of wine. And I'd say, oh, great, that means we increased by 6 degrees Fahrenheit. And you'd say, yeah, we increased by 10%. No, not necessarily, because I have the notion of delta or change, but there's no notion of ratios yet. There's no notion of percent more. Double the temperature isn't twice as hot. 0 degrees Fahrenheit is arbitrary. It doesn't mean no heat or no temperature. But what we can get here is now we can get mean and standard deviation. Also these ones, right? But also now we get mean and standard deviation as well as these ones here. Last but not least, in fact, in some ways, most significantly, ratio data scales are very powerful. They're found in physical sciences quite a lot. And these are now quantitative measures that do have a meaningful 0. Like in the case of wine, I look at it, it says here is content 750 milliliters. That's the volume of wine, right? Well, what's different about this reading is that if I had 0 milliliters, you say, well, that does mean there's no wine, 0 wine. If I double it and go to 1,500 milliliters, it is 2 times as much, right? It's a 100% increase. So this would be a ratio now comes into play. Delta is the same, yes, I have greater than or less than, equal to, not equal to, but I also can compute ratios and do things like geometric mean and coefficient of variation. So these are very helpful when it comes to new users, new data workers figuring out how to analyze their data. But remember, this gets to the controversial part. There's another paper that was written in 1993 by Paul Velleman and Leland Wilkinson called Nominal, Ordinal, Interval, and Ratio Typologies Are Misleading. Now their point, which is also the point made by John Tukey and others, is that this is a pretty rigid system and it doesn't really square well with reality, which is that oftentimes we don't know what the variable type is when we go to look at it. They used a fun thought experiment of soccer players and their jersey numbers, and they said, what if we gave jerseys to soccer players and some of them are freshmen and some of them are sophomores? When we assign the jerseys, we just throw them out there randomly. There's no thought given to who gets what number. Then that would be nominal. But if all the sophomores all of a sudden noticed that the freshmen seemed to have lower numbers, they started making fun of them, pointing and laughing, and it became a big problem, maybe the parents of the freshmen would say, is that true? Did the freshmen get lower numbers for their jerseys, and if so, why? And if you wanted to answer that question with analysis, you would need to treat the number differently, like a ratio. And so then in that sense, the type of data scale you want to use with a given variable type, in many cases is a function of the question you want to ask, not some a priori, sort of preordained, set in stone kind of scale that would have to apply. So that's a helpful thing to think about. It's true for a lot of these types of taxonomies or frameworks, is that it's helpful to get started and get your feet wet and start kind of learning. And then yes, eventually you need to shed it or make sure you're not being limited by it. And so that's a good thing to think about and remember as we apply these types of data scales. In future whiteboard sessions, we'll talk about how it actually matters, not only in terms of the statistics we can apply, but also in terms of the visualization types we make with these different types of data scales. Okay, thank you very much. Hope you found that helpful and look forward to seeing you on the next one. Bye-bye.